All right, hello everybody. Today's lesson is on the quadratic formula, and we're going to take a look at another method for solving quadratic equations. So today we're learning about the quadratic formula. Well, before we actually get into the formula, let's look at a few graphs. We have the quadratic equation y equals 2x squared minus 12x plus 10, and it's asking us to look at the graph but also to identify A, B, and C. So obviously A is 2, B is negative 12, and C is 10. So we write those down here. Then they want us to calculate B squared minus 4AC, which by the way is part of the quadratic formula. So B is negative 12 squared minus 4 times A, which is 2, times C, which is 10. That calculates to 144 minus 80, which is 64. All right, we'll keep that in mind for later. Let's go to B. In B, the equation is negative x squared minus 6x minus 9. And we identify A, B, and C. So A is negative 1, B is negative 6, and C is negative 9. Now we calculate B squared minus 4AC. So that's negative 6 squared minus 4 times negative 1 times negative 9, and that comes out to be positive 36 minus 36, which is equal to 0. Finally, graph C. So for graph C, the equation is x squared plus 4x plus 7. A is identified to be 1, B is 4, and C is 7. B squared minus 4AC is 4 squared minus 4 times 1 times 7, which is 16 minus 28, which equals negative 12. Let's look at some follow-up questions. First, we recognize the quadratic formula, and you guys remember that from a previous course. The quadratic formula says you can solve for x by calculating negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this b squared minus 4ac that we just dealt with is called the discriminant. And you can observe the discriminant and tell something about the graph. So let's look at these questions. Question 1. What do you notice about the number of real solutions and the value of the discriminant for the first function? Okay, so let me scroll down here. And when we look at this first function, we see that the function is crossing the x-axis at 2 places. That means we have 2 real solutions. And what was the discriminant? The value of the discriminant was positive 64. The conclusion is that when the discriminant is positive or greater than 0, then there's going to be 2 real solutions. And the 2 real solutions are the 2 points where it crosses the x-axis. Okay, look at question number 2. What do you notice about the number of real solutions and the value of the discriminant for the second function? In the second function, the discriminant b squared minus 4ac was 0, and you'll notice that the graph touches the x-axis at 1 point. So we notice that when the discriminant is equal to 0, then there was only 1 real solution. And finally, question 3. What do you notice about the number of real solutions and the value of the discriminant for the last function? Well, let's look at this. The discriminant, b squared minus 4ac, was negative 12, and the graph never crossed the x-axis. So when the discriminant is negative, there are no real solutions. And that's what this is saying. When the discriminant is less than 0, there were no real solutions. As a matter of fact, there's no real solutions, but there would be 2 imaginary solutions, which we will see later. All right, on the next page, we have 4 steps for using the quadratic formula to solve a quadratic equation. We recognize the quadratic formula over here, and then this is the quadratic equation in standard form. where it's a times x squared plus bx plus c equals 0. All right, so when the quadratic equation is written in standard form, we can use this quadratic formula to solve. The steps are first to write the equation in standard form, then identify a, b, and c, and then evaluate the discriminant, which is b squared minus 4ac, and then substitute all the values into the quadratic formula. So let's start with number 1. We have 4x squared minus 11x equals 3. We'll need to move the 3 over to the left side, so we subtract 3 from both sides. And we get 4x squared minus 11x minus 3 equals 0. We identify a, b, and c as 4, negative 11, and negative 3 respectively. The quadratic formula is written down, and then we simply substitute the a, b, and c values into the formula, which looks like this. The negative of negative 11 plus or minus the square root of negative 11 squared minus 4 times negative 3 divided by 2 times 4, which then gives us positive 11 plus or minus the square root of 121 plus 48 all over 8, which then becomes 11 plus or minus the square root of 169 over 8. The square root of 169 is 13. Then 11 minus 13 is negative 2, divided by 8 gives you negative 1/4. And 11 plus 13 is 24, divided by 8 is 3. So your two real solutions are negative 1/4 and positive 3. For problem number 2, we'll need to subtract 14x from both sides to get it in standard form and set it equal to 0. So the result is 2x squared minus 14x plus 19 equals 0. We identify a as 2, b is negative 14, and c is 19. Here's the quadratic formula, and here is what the function looks like when you substitute the a, b, and c values into the formula. That simplifies to 14 plus or minus the square root of 196 minus 152, all divided by 4, which simplifies to 14 plus or minus the square root of 44 over 4. We need to simplify the square root of 44 into 4 times 11, and the square root of 4 is 2, which comes out. And now we have 14 plus or minus 2 square root of 11 over 4, and then we can reduce by dividing by 2. So your final answer is 7 plus or minus 1 radical 11 all over 2. For question number 3, we have to distribute or FOIL the right side, or the left side, sorry. So you FOIL x plus 5 times x plus 1, and you get x squared plus 1x plus 5x plus 5 equals 10x. Now we have to move the 10x over to the other side. We add the 1x plus 5x to make 6x first. Now let's move the 10x over to the other side, and now we end up with x squared minus 4x plus 5 equals 0. Plugging the numbers into the quadratic formula, we get this, and then we simplify, and we get 4 plus or minus the square root of 16 minus 20 all over 2, which then gives us x is equal to 4 plus or minus the square root of negative 4 over 2. The square root of negative 4 is 2i. And now we have 4 plus or minus 2i all over 2. We can reduce by dividing everything by 2, and we get x is equal to 2 plus or minus I. For problem number 4, we want to move the 3x squared over to the left side. So we will subtract 3x squared from both sides. The result is negative 3x squared minus 2x plus 2 equals 0. A is negative 3, B is negative 2, and C is 2. and plugging those into the quadratic formula, we get this line. Simplifying, we end up with positive 2 plus or minus the square root of 4 plus 24 all over negative 6. 4 plus 24 is 28. And then we simplify the 28 using 4 times 7. Square root of 4 is a 2 that comes out. So we have 2 plus or minus 2 radical 7 over negative 6. We can reduce by dividing all of these numbers by 2, and we get 1 plus or minus 1 radical 7 over negative 3. But you remember that you can't leave a negative in the denominator of a fraction, so we simply multiply everything by negative 1, and so we end up with negative 1 plus or minus the square root of 7 all over 3. For problems 5 through 8, we complete the table. For number 5, we have the equation 10x squared minus x equals 2. First, we want to write it in standard form, so we'll subtract 2 from both sides and set it equal to 0. So a is 10, b is negative 1, and c is negative 2. The discriminant is b squared minus 4ac, which is negative 1 squared minus 4 times 10 times negative 2, which comes out to be 1 plus 80, which is 81. The number and types of solutions? Well, since 81 is greater than 0, that means our discriminant is greater than 0, we're going to have 2 real solutions. And those solutions are plugging it into the quadratic formula, the negative of negative 1 plus or minus the square root of 81 over 2 times 10 comes out to be 1 plus or minus 9 over 20, which simplifies to negative 2/5 and positive 1/2. For number 6, we want to subtract x from both sides to set it equal to 0. So we have a is 3, b is negative 1, and c is negative 7. The discriminant is b squared minus 4ac, which is negative 1 squared minus 4 times 3 times negative 7. Then we have 1 plus 84, which comes out to be 85. And then, since 85 is positive, we say that b squared minus 4ac is greater than 0. And that means we're going to have 2 real solutions. And the real solutions are, when you plug it into the quadratic formula, we have negative of negative 1 plus or minus the square root of 85 over 2 times 3, which then simplifies to 1 plus or minus the square root of 85 over 6. For number 7, we'll need to subtract 40x from both sides to set it equal to 0. So a is 16, b is negative 40, and c is 25. Plugging that into the discriminant, b squared minus 4ac, we get negative 40 squared minus 4 times 16 times 25. That simplifies to 1600 minus 1600, which is 0. When the discriminant is equal to 0, we have 1 real solution. And then to find that 1 real solution, we plug everything into the quadratic formula, and we get the negative of negative 40 plus or minus the square root of 0 divided by 2 times 16, which simplifies to 40 plus or minus 0 over 32, which is 40 over 32, which reduces to 5/4. For number 8, this is already written in standard form, so there's no need to move anything around. A is 2, b is 3, c is 4. Plugging the numbers into the discriminant, b squared minus 4ac becomes 3 squared minus 4 times 2 times 4, which is 9 minus 32, which is negative 23. (23) is negative, so therefore we're saying the discriminant, b squared minus 4ac, is negative, or it's less than 0. When it's less than 0, we have no real solutions, but instead we have two imaginary solutions. What are those imaginary solutions? We simply plug into the quadratic formula and we get negative 3 plus or minus the square root of negative 23 over 2 times 2, which is then negative 3 plus or minus I square root of 23 all over 4. All right, that concludes the lesson on the quadratic formula, and now you have the tools to finish your homework assignment.